Hi guys, welcome back to my channel Programming with Pirai. In today's video, we are going to see about merge sort. Okay, if I give you some elements in an array, then you have to sort it. Okay, in a efficient way. Then we can use what? A merge sort technique. It is one of the sorting technique. Okay, what is the technique that is used in this merge sort? Is divide and conquer. So this is the famous technique that is used in the merge sort. So what it signifies is, see here. What is this array? This array is whole set of my problem, right? So now I will divide my problem. I will divide my problem into a subproblem and subproblem to the sub-subproblem until my problem gets some smallest value. Problem with the smallest value. Okay, then I will find the solution for this. Okay, then I will find the solution for this and send it back. And by finding all the solution, I can find the solution for this sub-subproblem. And the sub-subproblem solution helps me to find the sub-problem solution. And this solution is used to solve this biggest problem. Can you understand this? So this is the technique called divide and conquer. Let us understand by taking this example. See here, this is the array example. Now, what it signifies? It signifies divide and conquer. So first divide it in particular partition. Okay, then do some process. Okay. So we are going to divide into two parts. We are going to divide this array into two parts. Okay. How many elements are there? 0, 1, 2, 3, 4, 5, 6, 7, 8. So these are the indices. Now, total 9 elements are there. So we can divide in 4, 5 or 5, 4. So this is the function, right? We will divide the whole array into a. So you can divide any way. You can divide any way. Okay. I prefer to divide in a 5, 4. 5, 4. Okay. I divided here. Okay, if we divide this, see here, 1% will contain what? 1% will contain 4, 2, 10, 1, 5, and 1% will contain 7, 3, 9, 8. So these are the portions that contains. Okay. Now again, see here there are how many elements? 5 elements. So I can divide it by what? 3, 2. Because in previous approach we divided by what? We divided a larger number, then only a smaller number. So in next approach also we should follow the technique. Okay, now again divided. So if I divide it, it will be like 4 to 10. Here comes 1, 5. Here it is 7, 3 and 9, 8. So there is no problem in this array. Okay, now again divided. If I divide it, it is like 4, 2 and here comes 10. Okay, here comes what? 1 and here comes what? 5. Okay, here comes what? 7. Here comes what? 3. Here comes what? 9. Here comes what? 8. Okay, now, just look at this carefully. It is what? These all are a single elements. These are all single elements. So beyond the single element, we cannot divide in the array, right? But only one element is containing 2 elements. This only one array contains 2 elements. So I will take individually 4 and 2. Okay. Now, my core logic is that I want to merge this 2 array. I want to merge this 2 array in a sorted order. Okay, if I merge this 2 array, it will be like 2, 4, 2, 4, and then now it's time to merge this 2, 4 and this 10. If I merge it, it will be 2, 4, 10. Can you understand this? So don't worry, I will tell you how to merge. That's how, just understand. If we merge it, it will be in sorted order. That's it. Okay, I will tell you how to merge it in a sorted order. Wait. Okay, now again, come here. It is what? 1 and 5. Okay, merge it. It will be 1 and 5. Okay, 7 and 3. Merge it. It will be 3, 7. Okay, 9 and 8. Merge it. It will be 8, 9. Okay, fine. Now, again, merge this 2, 4, 10 and this 1, 5. So if I merge it, it will be 2, 4. Sorry. It will be 1, 2, 4, 5, 10, right? Yes. Now, again, here also merge these 2. So it will be 3. Then it will be 7, then it will be 8, then it will be 9. Right? Again, measure these 2 things. When measure these 2 things, it will be 1, 2, 3, 4, 5, then 6, there is no, so 7, 8, then 9, then 10. So, this is the final sorted order. Can you understand this? So, what we have done here? We are just dividing. Or, we are just splitting the array into 2 parts. Okay. Now, for those individual parts, when it reaches the smallest subproblem, then what should I do? I just merge them. Okay. Now, we want to focus on only this merge, right? Because we already completed these two parts. These two parts we now successfully completed. Now, it's time to see what? Merge it. So, how to merge it? Okay. Let us understand first. Let us take, see here. Let us take this 1 and pi. This 1 and pi. If it is 1 and pi, right? 1 is here, then pi is here. Okay. If I merge it, it becomes what? 1 comma pi. Okay. Let us take a bigger example. Like, let us take this 2 4 10 and with this 1 pi. Let's take 2 4 10 1 comma pi. Okay. Now, listen carefully. This is an important method. See here. First of all, I place a pointer here and I will place a pointer here. And I will take a array. I will take an array. Now, just see here whether this 2 is lesser or this 1 is lesser. And also, I want you to remember that whenever we are just merging, this 2 will be what? In a sorted order. See here. In everywhere, it is in a sorted order, right? In single elements, there is only one element. So, it is obviously sorted order. Okay. And here also, it will be sorted order only. I will tell you why after explaining this. See here. 2 and 1. What is smaller? 1 is smaller. So, put to 1. And move this pointer to this pi. Can you understand this? Because it is in sorted order. These both are in sorted order. So, if this 1 is lesser than this 2, it means this 1 is lesser than all elements in this array. And all elements in this array, right? That's what is meaning. Yes? Okay. Now, where 2 or this 5 is smaller, 2 is smaller. So, put the 2 and move here. Now, 4 or 5, 4 is smaller. Put the 4 and move here. Now, 5 or 10 is smaller. 5 and move here. Unfortunately, we are end up with no elements. So, after this, whatever element here, we will take that into our result. So, there is only 10. So, we took that in our result. It is what? It is again a sorted order, right? This is again a sorted order. Can I understand this? So, this is what? A merge function. Whenever we are just merging two values, I will do this. Can I understand this? Yes. So, that's what I am just told you that whenever we are merging two values, we will always get what? A sorted order. Again, here also sorted order, here also sorted order. Again, when I am doing it, it will become what? A sorted order. Then again, here also sorted order, here also sorted order. So, again I am doing, so it will be what? Sorted order. So, I can say whenever it is going up, it will be what? A sorted order. Can you understand this? So, these are the 3 steps we are just focusing in merge sort. So, what we are doing here? We are doing a recursion. We are doing a recursion because we are just dividing by 2 parts, right? 2 parts. Okay. Now, just tell me what is the time and space complexity for this solution. I can say you that time complexity will be, just observe carefully. First of all, we are doing what? We are just splitting it into 2, right? Splitting into 2. And if I tell you that each time it is dividing by what? Dividing by 2. Each time it is dividing by 2. So, maximum goes to up to what? Log of the length of this array. Can you understand this? See here, if the length of this array is 8, let me write here, is 8, then it will be further divided to what? 4, then 2, then 1. So, I can go up to what? Up to 3 times from it. So, it will be what? Log of the length of the array, okay, into, I'm doing what? I'm doing a merge function here, right? I'm doing a merge function. So, for doing this, see here, what I'm doing, I'm just iterating to this each and every element and these elements. So, I can say it will be n times s. So, it will be n. Okay, what's space complexity? Okay, the space complexity is something like, we are doing here what? We are doing a merge function. For this merge function, what we are required? We are required an auxiliary space. So, this is the auxiliary space we require, and also it is what? It is a recursion. Whenever we are going for a recursion, a recursion stack is created, right? And this recursion stack is also taking some space. So, overall, the space complexity will be what? O of n. So, this is the time and space complexity analysis. Hope you understand this, right? Okay, let us take this as our example. Now, we can write the code simultaneously, okay? Now, initially what I am doing here, I am just splitting, right? I am splitting into 2. How? I am splitting 7, 6, 2 here, right? 7, 6, 2. So, without splitting like this, we can split like a range, like 0 to 2. What is my range? It is 0 to 2. I am going to split like this, okay? Now, How to split? We are taking the mid, right? So just come up with me. Def merge sort. First of all, merge sort. Oh, what are the parameters I need? I need this array for a reference. And mainly I need what? A start and the end, right? I need a start and the end. Okay. Now, how to find the middle point? This middle point is what? This 2, right? Okay. How to find it? So I can easily find like mid is equal to start plus end minus start divided by 2, right? So by using this formula, we can find the midpoint. Now, what should I do? I should split into 2 recursion calls, right? So what is the split function represent? It is like, hey, do a merge sort again. I will call this recursion call again, okay? And what should I pass? L, comma, what should my starting point here? Starting point remains as it is. So give starting point as it is. Okay, but I do what? The mid is my reference. Because I told you, right? For pi, we will split like 3, 2. So I just go up to what? Mid. Okay, now next step, what should I do? I should go for the merge sort of L, comma, starting point should be what? Starting point should be mid plus 1. Mid plus 1. Because while I'm going here, what is my index? My index ranges from 3 to 4, right? So mid plus 1, but end remains end itself. So this is the initial representation. Okay. Now, whenever we are calling a recursion like this, first this call will completely finish. Then after this only, this call comes, right? Okay. Then, first of all, this recursion call should be completely finished, right? So this will be stopped. This will be not executable. Okay. Okay. Fine. Let me go beyond this. Okay. Now, again, what is my value? It is 762, right? This will be not the value, just for the visualization I kept. Okay, now, again, what should I divide? I should divide up to this mid, right? Up to this mid. So it will be 0, 1, 2. So I am just dividing 0, 1. Can you understand this? Okay, now what are the elements? It is 7 and 6. Okay, again, I will divide by what? I will divide, what is the mid now? It will be 0 and 1. So 0 plus 1 minus 0 divided by 2 is what? 0. Totally 0. So it will be what? 0, 0. What is the 0, 0? It is 7. It is 7. So I stop here, right? I just stop here. So what is my base case? What is my base case? My base case is something like if my start is greater than or equal to my end, then return. Okay, you can do like this, or you can also put like here one condition. If start is less than end, then do this. Else don't do anything. You can either use this or this. You can use any of your choice. Okay. What is the next step? It goes for the next recursion call. Now it executing this step. Okay. Okay. Now L, comma, mid plus 1 to end. So what is the mid plus 1? It is 1. So 1, 1, which is what? As 6. Okay. Okay. Again it returns back, right? Here it returning back, and here also it return backs. We returning back. What should I do? I should merge, right? I should merge it. So I am going to write a merge function here. Just a merger or L, comma, start. We need start. We need mid. Then we need end. Okay, because from start to mid, it is one set of array. And from this mid plus 1 to end, it is another set of array. That's our visualization. But in real term, it is what? I end this alone. Okay, now it's time to write the merge function. Okay, def merger of what are the elements? What are the parameters? It is yes. L, start, mid, then end. Okay, so this is the merger function. Now, inside this merger function, what I'm going to do? First of all, I'm just creating an array, right? Okay, I'm creating an array, a list. Okay, now inside this, what should I do? I should compare both of them, right? If, take for example, it is 1, 2, 10. And here comes another array like 4, 5. Then first of all, I'm keeping a pointer here, right? So to keep the pointer here, I will take a low, which is pointing to what? Which is pointing to the start. Okay, this should be going up to what? Going up to the mid. Going to the mid, because it is what? Started to mid is the first range, and mid plus 1 to the end is the second range. Okay, then what is the second range? It will be I, which is equal to what? Which is equal to mid plus 1. Can you understand this? Okay, now let us begin. Why? What is my condition? My low should be less than the mid. Less than or equal to the mid. And My I should be what? My I should be less than what? My end. Less than or equal to end. Okay, up to this, what should I do? I should merge, right? Okay, while merging, what is my condition? If my nums, let us take this array as nums, okay? Let's take this as nums. Nums of low is less than nums of I, which means what? Which means this value is less than this value. Then what should I do? I should make my low minus value to be inserted in the ARR. So ARR dot append of nums of low. This I appended. Now low plus equal to 1. I'm just updating my load with the next pointer. So I just updated it. Can I understand this? Okay, now I'm just comparing these two, right? Okay. Now, what if my nums of low is greater than nums of I or equal to? Okay, so instead of taking this entire thing, we can take what? Else part. This is what? Else part. Okay, else, what should I do? I should append my ARR with what? Nums of I. And this I'm updating my nums of I in my ARR, and I will be what? I will be plus equal to 1. So see here also the low only smaller, right? So the pointer moves here. Once the pointer moves here, when I am comparing this 4 and 10, this condition will execute. This condition will execute, and this 4 will be kept, and this pointer will move to this way. Can you understand this? So this whole merge function, but still we are left out with some value. Okay, let us understand what it is. Okay, I am comparing this 4 and 10. Now what's smaller? This 4 is smaller, so I kept 4. Now I am comparing this 5 and 10. What is smaller? This 5 is smaller. Okay, I kept, and the pointer comes to out of bound exception. Sorry, out of the range, right? Now this 10 is not filled, right? So we are now going to fill the remaining elements. Okay, how to fill the remaining elements? Okay, I want to check whether while my low pointer is less than or equal to mid. If it is less than or equal to mid, what it signifies? My low pointer doesn't execute, right? It has some elements still. So ARR dot append, just append my nums of low and do a low plus 1. Can you understand this? Now, do the same step for I also. If I is less than or equal to end, then what should I do? I should append my nums of I. And do what? I is plus equal to 1. Right? Okay, now we are done successfully. Now it's time to make this auxiliary space elements into a nums element. Right? Like we are just updating our nums element. Okay. Now how to do this? Just take a for loop for I in range of from where to where? From start to end. Okay, in Python we want to put what? Plus 1. So end. Okay, from start to end, what should I update? I should update my every values in ARR to the nums. So nums of I should be updated to what? ARR of I. Simple, right? Can you understand this? Yes. So see here, ARR, it is not ARR of J, it is ARR of J. So J plus equal to 1, and in here J will be what? 0. Can you understand this? Yes. So this is my word set of code. Yes. Now let us try run it. Okay. Now again, this will be merged, right? This will be merged. Okay, it is what? Let me write down. It is what? 7 and 6, right? So it is individually. Now, one pointer is lying here, one pointer is lying here. Now, whether the 6 is smaller than 7? Yes. Yes. So I will put the 6 first. Then I will put this 7 next, right? Now, I will be updating the 6 and 7 in what? In this 2 integers. So now my array looks like 6, 7, 2, 8, 1. Can you understand this? That's why our array looks like 6, 7 now. Visualization, right? Again, it goes for the recursion call now only. It goes for the recursion call now only. And now it will be like 7. Sorry, it will be 2 only. It will be 2 only. Now, I am just doing a merge operation in 6, 7 and 2. So it will be like 6, 7 and here comes 2. Now, one pointer is here, one pointer is here. Now, tell me what is smaller value? It is 2, right? So 2, but remaining values will be added simultaneously. So it will be 2, 6, 7. So from this 0 to 2, From the 0 to 2, my array now updated as what? 2, 6, 7, and 8, 1. Can you understand this? Can you understand this? Yes. Now, again, it goes again. Now, it's time to take the 3 and 4. What is 3 and 4? It is 8, 1, right? 8, 1. Again, it goes here. When it goes here, it will be 3, 3. And it goes here, it will be 4, 4. The range of start and end, right? Now, it will be what? Only 8. And it will be what? Only 1. Now, when I'm merging these two, it will be like 1 and 8. It will be 1 and 8. What does 1 and 8 signifies? In this step, it will be like 7, 6, 2, 1 and 8. Like this only 8. Okay? For your representation, I'm just putting like this. Okay, now, again, when I'm going to the further above, here it is what? 7, 6, 2. Here what? It is, here it is what? I kept it here, right? 2, 6, 7. 2, 6, 7. It is going for recursion call. It is a return value. And here, what is the return value? It is 1 and 8. This 1 and 8. When I'm doing a merge function for these both, I will be resulting in what? 1 first, then 2, then 6, then 7, then 8. So what's my answer? Let me write here. That's no space. 1, 2, 6, 7, and 8. So this is my output. Can you understand this? Okay. After understanding this, just dry run by yourself. Because it is so complicated. Here I wrote so many things. Okay. So just dry run by using some example, your own example. Now, let us see the code in our compiler. See here, the same code I wrote in a paint file. I just wrote the code in the compiler. See here, everything was same. Okay. Now, let me run it. Yes. Let us consider same example. What is that example? 7, 6, 2, 8, 1. So 7, 6, 2, 8, 1. Sorted, right? Sorted. Now, just observe here. We have done what? A simple merge sort. But in merge sort, we have various combos. Like they will give array like this: 2, 6, then 3, 4, then 1, 5, then 10, 2, like this. Okay? And we want to sort this array with respect to what? With respect to the 0th index of the each and every element. So this is the important sorting technique. This is also an important sorting question. Okay, by using what? A merge sort. Okay, what should be a result? It should be like, first of all, this 1 is smaller, right? So put to 1 first. Then 2 is smaller. So put to 2 next. Then 3 is smaller. Put to 3 next. Then put 10. So 10 is the last. Can you understand this? So this should be my output. So this is one type of the sorting question. And another type of the sorting question is something like they will give two arrays like 1, 2, 12, 10, 3. And in another array, it will be like 3, 5, 6, 7, 8. Now you want to sort this array with respect to this array. So if I sort this array, what is my output? It will be 1, 2, 3, 10, and 12, right? Now, what is the ones position? It is 3, right? So just update 3 here. And at 2, it is 5. Okay. At this 3, what is the element? It is 8. So put 8 here, then put 7 here, then put 6 here. So this is my output. Can you understand this? This one type of a sorting question. So for this question, you should use what? A merge sort algorithm. Okay. So let me show you the code. See here, this is the code. This is the code for what? With respect to some array. Okay. And then this is the code for with respect to a 0th index element. Okay. Try your own way of sorting. Okay. Try your own problems like this. Okay. Similar problems. And I will share this Google Colab in the description. Just go and watch this code. Fine. Thank you.